The climate-friendly hydrogen economy, powered by renewable energy, is set to grow, ideally on a massive and immediate scale. The pressure to deploy this technology broadly is intense. What often goes unnoticed is that even though the foundations for high-performance electrolysis stacks have long been in place, mass production takes more than just the technology. What's currently missing, for example, are standardized methods to consistently test and compare performance and quality. What role do test benches and measurement methods play in the further development and industrialization of electrolysis stacks? I'm an optimist, but I still wonder whether this balancing act can truly be achieved. Hello and welcome to our new episode of minus 253 degrees Celsius. It's the monthly expert talk that gets to the point, to the boiling point of hydrogen. And today I'm in Linz in Austria, and I'd like to welcome Philipp Mayr. Philipp is our hydrogen test engineer in the testing and reliability team here at the Bosch development site in Linz. He's a test bench expert and responsible for test bench procurement and commissioning. Hello, Philipp.
Hi, Keith.
So, Philipp, straight to my first question. There's a lot of momentum right now in the development of a climate-friendly hydrogen economy. Numerous electrolysis projects have already been announced, and both startups and established companies seem to be positioning themselves. Yet in many cases, final investment decisions seem to be on hold. Now, at the same time, advancing the technology demands precise, data-driven work on test benches, a process that takes both time and care. Do these different speeds clash?
Actually, I don't think that there is a conflict. So we want to build a solid product. And for a solid electrolyzer, you need a good development, and a key part of that is detailed testing. We have to test as accurate as possible. We have to consider a lot of factors in testing. For example, we consider the test bench working principles itself, the controls of the test bench, the sensor accuracies, and of course, in the electrolysis, a key parameter is the water quality. It's decisive that we have an ultra-pure water at highest quality. We generate results, and we always have to think, do we measure the stack behavior, or are the results influenced by the testing procedure or by the boundary conditions itself?
Is the test bench infrastructure agile enough to match the pace and volatility of the hydrogen market?
We try to be as fast as possible. We are in regular exchange also with our other locations, the pre-development team in Tilburg, for example, in the Netherlands, or the production plant in Germany, in Bamberg. We also contribute to research projects. So we also contribute in the fundamental research in this topic.
How can I imagine working on a test bench? I can't really picture it in my mind.
Very simply explained, we want to test the electrolysis stack under clearly defined boundary conditions. We measure the stack behavior, and from this data we draw our conclusions and try to improve the stack. The test bench, in rough words, controls 5 major parameters. The test bench has to precisely control the anode pressure, the cathode pressure, the electric power supply, the anode water flow, and the anode circuit temperature. These are the main parameters. In detail, of course, the test bench is much more complicated with much more measurement equipment.
Are we actually doing something differently compared to the other players in the market?
A really important factor is that we also test the full stack. That's the real stack size that we also deliver to customers. A lot conclusions can be extrapolated, but still we need final clarity how the full stack behaves, that the extrapolation is not valid from smaller test samples to the full stack, or that we miss some effects on smaller test samples. Both is important. Develop on smaller test samples, but also to finally validate on the full stack.
That sounds to me like safety is an important factor too.
Of course, safety is an important factor besides lifetime and efficiency. Along with our CE certification, which we do for every customer stack, we have a lot of risk assessments, detailed risk assessments, but also for our development samples, we do a detailed risk assessment. So safety is a major consideration along the whole testing procedure.
Another thing I've been wondering about, Philipp, innovation often thrives on rapid iterations and creative freedom. Does that somehow naturally conflict with the need for standardization?
I would say we need both. We need in testing always the flexibility to also conduct special tests. But on the other hand, standardization is needed. So we have to be able to compare the measurements on future stacks also with our already gained data. Therefore, we need to standardize the testing procedure. This is a major point we contribute in Linz. But in general, standardization is also needed in the whole field of electrolysis, where we also contribute to define the standards in this field generally.
Now, you mentioned the future. How do you assess the long-term developments in your field for the year 2050?
I'm very optimistic. I'm convinced of the hydrogen economy. There will be a lot of hydrogen needed, but there's already the demand now. For example, the pharmaceutical industry or the semiconductor industry needs pure hydrogen. So I'm quite optimistic that this will be an important field in the future economy.
Well, I started out being optimistic. Now I'm actually convinced. Thank you very much, Philip, for giving us insights into your very valuable and exciting work and for raising our awareness of the importance of testing, collecting and evaluating data, all for the evolution of electrolysis stacks. Thanks once again. And I want to thank everyone here for joining us today. Let's keep the positive energy flowing and don't miss our next episode of minus 253 degrees Celsius. It's the monthly expert talk that gets to the point, to the boiling point of hydrogen.